Here is a matching type question on general organic chemistry. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us first understand the key concept here. Conjugation requires alternating single and double bonds, or p orbitals, in direct overlap. Two double bonds separated by exactly one single bond are conjugated. An alene, C is equal to C is equal to C, is cumulated, not conjugated. Isolated double bonds separated by more than one single bond, sp3 carbon between them, are not conjugated. Structure A, the molecule is a 1,2-dihydronaphthalene tetraline derivative with a methoxy substituent on the aromatic ring. The aromatic, benzene, ring is fully conjugated within itself. The benzene ring is also fused to a ring containing one double bond at the ring junction side, making those double bonds conjugated with the aromatic system. The methoxy-oxygen lone pairs can conjugate into the aromatic ring. Therefore, the entire aromatic ring plus the adjacent double bond in the partially saturated ring plus the methoxy group's oxygen form the conjugated portion to be circled. The saturated CH2 portion is not conjugated. Structure B, CH2 is equal to C is equal to CH, CH is equal to CH2. The central portion CH2 is equal to C is equal to CH is a cumulated diene, alene, which is not conjugated in the classical sense. However, CH is equal to CH2 at the end, the single bond between is equal to C is equal to and CH is equal to CH2 connects a cumulated system to a double bond. The last two double bonds, is equal to CH is equal to CH2, are conjugated with each other. Thus only the CH is equal to CH2 terminal portion, the diene part, is equal to CH is equal to CH2, is conjugated. The alenic portion breaks classical conjugation. The answer circles the CH is equal to CH is equal to CH2 portion, the conjugated diene end, excluding the alenic C is equal to C. Structure C, the molecule shows a 6-membered ring with one endocyclic double bond and a side chain bearing two double bonds. Examining the connectivity, if two of the three double bonds are separated by single bonds, conjugated, those are circled. The isolated double bond, separated by an sp3 carbon, is excluded. The conjugated diene portion within or appended to the ring is circled. Structure D, a linear chain with three double bonds. Two adjacent double bonds separated by one single bond are conjugated. If the third is separated by an sp3CH2, it is isolated. The two conjugated double bonds are circled, the isolated one is not. Why other regions fail? sp3 carbons break conjugation by interrupting p orbital overlap. Cumulated double bonds, alenes, are not classically conjugated. Only regions with continuous alternating pi bonds qualify. Therefore, the correct answer is type visual. Note answer is a set of redrawn structures with conjugated portions circled, not plain text. Structure A, methoxy fused ring plus exocyclic alkene system entire extended ring plus chain conjugated system circled. Structure B, CH2 is equal to CCH is equal to CH is equal to CH2 type chain entire chain circled as fully conjugated. Structures CD, diene fragments attached to a ring only the conjugated double bond portion circled, excluding isolated double bonds. See answer key page IDX 73, page 74, upper middle region for exact circled regions. Therefore, the correct matching is, note matches answer I as a set of redrawn structures with conjugated portions circled, not plain text. Structure A, methoxy fused ring plus exocyclic alkene system entire extended ring plus chain conjugated system circled. Structure B, CH2 is equal to CCH is equal to CH, CH is equal to CH2 type chain, entire chain circled as fully conjugated. Structures CD, diene fragments attached to a ring, only the conjugated double bond portion circled, excluding isolated double bonds. See answer key page IDX 73, page 74, upper middle region for exact circled regions, type matches visual.